So we'll start the session. Hi everyone. Thank you all for joining with us for the final workshop of our IEEE IES Generative AI Challenge Workshop series. And previously we had a one workshop on generative AI and applications in industrial systems, and this will be the second workshop, so which will be targeting about academic publishing and IEEE conferences, specifically in IEEE conferences. So main reason for organizing such workshop, because one of your objectives of this hackathon would be publishing a paper, at least creating a manuscript which will be eligible. Like if you selected to the top 6 places, you'll be eligible for a travel grant as well as an opportunity to present that manuscript at ICON 2024, which is the flagship conference of Industrial Electronics Society. So in order to get accepted to that ICON 2024, your manuscript has to be in a good quality to pass the reviewing stages and all these different stages. And Professor Dustin will be here to teach you, and then to give his view on how to create a very good level of academic manuscript targeting ICON 2024. So he himself has co-authored more than 100 academic research papers from journals and different IEEE conferences and other conferences. And he's a associate editor for 4 journals as well. So he's one of the best speakers that you can hope for this workshop domain. So without taking further more time, so Professor Dasit, you can start.
Thanks, Lakshita, for a glowing introduction. Yeah, there's many research papers, as you've probably seen on Scholar, so there are many authors, and hopefully most, if not all of you, will become even more successful authors and editors in the future. So I have only a few slides because I'm keen to hear from you in terms of the challenges that you might be facing. So I'll start with what I have, and then I would like to open the floor for discussion, comments, questions, because this is it's a practice. Regardless how many slideshows or presentations you go to, it's actually when you start writing the paper or writing in general that you start facing issues. It's almost like riding a bike. So you have to do it to understand what are the challenges, and then when you're actually doing it, only you'll find out that there are things that are probably not in your control, or challenges otherwise. At the same time, there's also, you would have seen some of this already, there's lots of content online about how to write better and how to write more effectively. So I don't want to reinvent the wheel, so I'm going to keep my slides minimal, and at some point we'll point you to some other resources that we thought are reasonably good for you to have a look. But it's really your effort, so you have to come out of the maybe an experimental mindset and embrace the writing mindset. This is a challenge, and I've also supervised many PhD students, and I see that it becomes a bit of a roadblock when you have to communicate your research. You might be excellent at the experiments and the research methods and experiments and simulations or comparisons, but then you have to cross that bridge and start writing and communicating this research as well. So on that note, let's get started. I see a number of AI companions in the, these are new to me. Maybe when we start the Q&A, you can tell me how you use this. And the other thing with academic writing is we have our friend ChatGPT. So we'll discuss pros and cons of using it as well. All right, I think you can see my screen. So So before we get into academic writing, we look at research methods. And generally, uh, not always, but sometimes I find that research students or even people presenting at conferences are not very clear what their research method is. So if you think of the universe of research, so all forms across all disciplines, there's three main categories: qualitative, quantitative, and mixed methods. So qual research is not something we do, but it is equally important because research is across the board, across all disciplines. So if you think of a generative AI example, so I think so imagine you've built a generative AI smartphone application with a few features of image generation, text summarization, chatbot, and so on. So you built it, but now you want to evaluate how effective it is when you actually people start using it. At that point, we have to use qualitative research methods. So interviews, focus groups, ethnography, case studies are these qual research methods that might be a bit foreign to you because I'm assuming most of you are from the STEM disciplines, the technical disciplines in university or in education, tertiary education. So this might be an unfamiliar term or research method, but it is there and it is used quite widely. So if you think of the pandemic, a lot of qual research methods were used because that's how we understand how the pandemic affected people, how lockdowns affected, or how different vaccinations and after effects. So that's a lot of qual research. The second one, which is what we relate to more prominently, is quantitative research. So there is a quantification of what we are trying to evaluate. So there's experiments, simulations, surveys, control studies, and so on. And then there is a combination of these mixed methods. And more often than not, you would try to belong to these mixed methods because then you have quant and qual. But what we find with AI research is that it's purely quant. So this is a bit of a challenge for academics in the broader landscape because we are really good at we are really good at performance of AI. So we evaluate the hell out of algorithms and we make sure they're performing at 99%, or we keep adding many layers to our CNN until we hit 99%, or we keep fine tuning or transfer learning, one shot, zero shot learning into a generative AI model so that the performance improves. But we don't consider the after effects or the challenges of what happens when we implement this model in society, in an organization, and humans start using this. So that's the qual research. And this is also what we see in our daily lives in terms of government policy, in terms of social media. There is a lot of anxiety associated with the use of AI because AI research so far has only focused on performance, not so much, has focused on technical performance, increasing your classification accuracy or your F1 score and similar metrics. So technical performance metrics and not so much the human focused or human centric performance metrics. So how good is this AI for society, for humans, for marginalized communities, for minorities, for majorities, and so on. That's where the mixed methods is important. But on the other hand, AI would not be this good if we had mixed methods from the start. So we really needed to push the technical performance of AI to get to this point. And now that we have AI quite widely used and appreciated, acknowledged, and respected, now we can look at the mixed methods. So this is a broader, this is not related to the hackathon, but this is the broader context of AI research. So I'm trying to share with you some of these insights as well. So it's a learning process. You understand what AI research, the current state of play, and where the opportunities lie. So, a question to the audience: out of these quant and qual and mixed methods, what's your preferred research method? So if you not if, but we are all doing AI research, what's the preferred research method for AI research? It's on the slide, so you can pick a term from this. Simulation, that's good. Thanks. Anything else that jumps out at you? Not too eager to respond to this question. We like to listen, do we? Yeah, no responses. Okay, so it's experiments and simulation. So simulation is correct. But most of the time it's experiments. So if you think of AI, it starts with data. So if you think of classification or prediction models for conventional AI, we already start with data to understand the data that represents the problem for classification or prediction. And then we run some experiments, and then we try to find what the performance is, what the classification accuracy, F1 score, and whatever metrics. And then that's conventional AI. But if you think of generative AI, also experiments. So we have generative AI models. So either a GPT or any of the other models. And then we have our own data set or our own problem description that we want to explore using this model. So we run experiments. We run experiments without data, just on the GPT, or we run experiments with our own data on the GPT and how it responds to things like fine-tuning or transfer learning. So it's important that you understand what this research method is that you have to practice, experiments and simulation in the quantitative research category. Okay, so I think we need to understand and appreciate this. Okay, so once you've determined a research method, there has to be a research approach. So how do we go through the research process and reach the outcomes that we desire? So since you've already started the hackathon, you are following a cut-down version of this, but this is your formal research approach. Start with a research question or a problem. We try to find out in the literature if other people have solved this problem and what are their results. So we conduct a lit review. And then we find out that, okay, my research question is generative AI in healthcare. And I've seen that other people have done generative AI in industrial applications. Let's say smart energy. Others have done smart energy for 5 different research problems. But I think there is an opportunity for a 6th research problem, and that's step 3. So I start formulating my research objectives or hypothesis based on this. So can we use generative AI to improve solar performance? Or can we use generative AI to improve net zero emissions awareness in communities and so on? So that's the formulating the research hypothesis. Then we select the research method, so what you saw earlier. Then afterwards, we try to identify the research design. So method and design are going to details. Then we start building the model. This is your AI model. And then experiments, evaluation against different metrics. Then we try to interpret the results, and then we document the results, and then we think of generalization. So it worked on your data set or your selected data sets. Can we start applying this to a different data set or a different problem? So generative AI works for energy. Can we start applying generative AI for healthcare? So this is the expanse of research. You start with a research question, and then you start trying to solve this research question. And then you try to make sure that the solution you found can be applied somewhere else as well. And that's what makes it research. So some of you might be working in industry. This distinction between research and industry projects or even software development projects or AI development projects has to be distinguished. So research contributes new knowledge, whereas a application-focused project will only produce a system or a solution. It will use pre-existing knowledge to produce this system, but it won't do anything that is new, or there is no expansion of knowledge in the world when you do an applied an application development. So it can be a software development, it can be a exploration of capabilities that doesn't produce new knowledge. You have to cross that boundary to produce new knowledge of from hypothesis to results to documentation. That's where you need to have the research mindset and the research approach established. All right. So at the risk of self-promotion, I'm going to show you this AI life cycle. I think it's a good research paper for all of you to read. So I'm going to show this on Scholar. This was authored by by me and another colleague. So if you type AI life cycle on Google Scholar, I'm assuming you know how to use Google Scholar. This is how you will find related literature, and usually the links here will give you free access. If you can't get free access, like most of the IEEE papers are paid subscription, but you can write to the authors and ask them to send you a version of their paper. So if you don't have access to a library that pays the subscription, then you can ask the authors to send it to you. So we scroll down to this one over here. So this is the paper so it's an open access paper, and it talks about a life cycle for building AI models. So I'm going to leave it with you for you to read and try and understand how this works. But disclaimer, I've authored this, so there's obviously an interest in sharing this with you. But also this was written before generative AI became so powerful or effective. So it excludes generative AI because it was published in 2022, June, but it was written in 2021. So I'm introducing in this paper an AI life cycle, which is comprehensive. It talks about things like AI ethics, data preparation, exploration, and I go into each phase of this, and I describe what happens in each of these. There's also the AI capabilities. So this doesn't have generative AI, interesting. Prediction, classification, association, optimization. Yeah, and also, yeah, something of a organizational practice and AI taxonomy. So I'm going to leave that with you, and you can have a look at it later. So if I go back to research approach, this number 6, build a model, is mostly to do with these. So although generative AI is not discussed in the paper, you can adapt this approach for your research as well. So this makes it, for your project as well, this makes your research contribution strong because you are using existing research to advance your work. And that means the methodology has been accepted because if you know how Scholar works, this has been cited by 47 people for 47 other papers, and that's what you should aspire for, citations in your work, of your work. And that means people have read this paper and he found it useful. So that means it's good research. One way of finding good research versus bad research, because Scholar has about 1 million research papers, or 1 billion, is to look for the number of citations. And it's not just me promoting this. Other people have also read this paper. That means they found it useful. And it's something you can use to understand all 11 steps, really, especially this number 6, building the model. All right. So now the hackathon is looking at an AI research project that delivers an AI model or a system or an algorithm or application. So why do we have to bother writing a research paper? Which might be a question that popped into your mind. Good question. Well, firstly, because there is an incentive. So we will, one of the prizes, the awards of the hackathon is that you will receive a scholarship, a travel scholarship to go to the conference and present your work, which is a good incentive. It's Chicago, a very large city, and it's a good conference. At least 1,000 people will be attending this conference, and some of them, or at least most of them, hopefully most of them, will be listening to your work. There will be events at the conference, so things like tutorials, workshops about other parts of the society, other areas where generative AI is used. Also things like lunch events and dinner events, banquets, and so on. So it's a bit of entertainment, and also, well, if you are interested in research, this is your first step into a very formal research meeting, a conference. So that's your kind of selfish incentive, self-centered incentive rather. But more generally speaking, why do we write research papers? Because we want to share this knowledge with the rest of the world. So why do we do research? To push the boundary of new knowledge. And that's the main reason to write this research paper, because we want to share this knowledge in a format that is understandable to other researchers. So we can't just write this in an email or write it on Twitter or Facebook as a status update, because no one looks at those looks in those locations for new research. But other researchers across the world are very familiar with research papers, and that's where they will start looking. So I say research paper, my first dot point here. It has many names: research paper, research article, research manuscript are all the same thing. It is more formal when you say it's a manuscript or it's an article versus a paper, because a paper can be many different things. So I prefer to use research article or manuscript, and you can also adjust your language accordingly if you like. So research papers are one way to communicate research, but also recently with generative AI, a lot of the companies, the commercial entities like OpenAI, DeepMind, have started. Well, they have better models because they have more resources, maybe. And what they have started doing is they don't publish research in a academic sense. They just publish research in a blog post or in an archive paper, if you're familiar. So it's a document repository, or it's on their website. So this is another form of publishing research, or they present these in tutorials, workshops, Zoom calls, and so on. But you have to be highly accomplished to follow this path, which probably you and I are not. And that means we have to stick to the status quo, what is accepted across the world, which is a research article or manuscript. So why do we write the paper? Firstly, to contribute new knowledge. And this is the reason why we decided to do research in the first place, and not to build a software application for financial reasons, or to conduct an exploratory study of different tools, maybe financial reasons or other reasons. So our main goal is to contribute new knowledge, and that's why we are doing research, and that's why we have to write it as a paper. When you write it as a research paper, and especially when you submit it to a conference or a journal, it gets what's called a peer reviewed. So peer review is a peer is a person that's doing similar research to you. So it can be a PhD student, it can be a professor, it can be another academic at a different organization. So peer review is highly important to make sure that we maintain quality of our research. If our papers don't get peer reviewed, you can think of a peer reviewer as a critique of your work, which is someone who tries to poke holes in the research and question why you did certain things. So this is why research is called to be rigorous or robust, because there is a very strong peer review community around research. So any discipline, if it's healthcare, if it's medicine, if it's engineering, if it's basic sciences, or if it's physics and math and any other discipline, or even business and commerce, there is a strong peer review community that evaluates the quality of the research and provides validation for the outcome. So if you think about it, you've come up with this amazing AI model, but only you have seen this. So no one else across the world has seen this, and only you are saying this is really good. So what peer review does is it confirms or rejects your position. And the peer review is usually 2 or 3 people, and they present very diverse opinions. Is this good research? Have I seen this research before? Then it's not research. It's just a repetition of what's already there. So peer review brings the rigorous nature of research into its capabilities, and that means a lot of the research that we find on Google Scholar is good. So peer review happens before the research is published, and after the research is published, you have the citations. So has anyone else read my papers? Has anyone else found this work to be useful? So that is also peer review or validation, but after it's published. Before it's published, it has to follow through some checks. And that's another reason to publish our research, because until we publish, we don't know if it's good quality. And some of you who have published before will appreciate how soul destroying some of these comments are. When you receive the comments, they actually criticize your work, your effort of 2 months, 3 months, or of many nights of sleepless nights are being criticized by people you don't even know. But this is part of research. You need this check for research to progress. And without that check, research is just, research is not rigorous. It is not, we cannot accept. So even I wouldn't read research that is not peer reviewed unless it's published by OpenAI, who does not believe in peer review because they're so good, as I said before, or a research that is not cited. Then unless it's very new, like if it was published last month, we haven't had time to cite the paper, so that's because it's new. So these are some of the indicators of good research. And if you are interested in doing research, then might as well do good research. So that's the second reason to publish the research, because bad research is a waste of time, really. Benchmarking and comparison. So similar to peer review, it gets compared with other research, and that means we get to evaluate how good your research is. And it might be that your research, that your AI model is proven to be faulty or is underperforming, but that's okay because you've contributed that knowledge. So even a failed research hypothesis is a good research. But if you fail many times, that's not really good. That means you're sort of playing a game there. So failed research where it's replaced next year or next month is also good because you push the boundary. So it's been accepted for publication and you push the boundary. So fourth is reproducibility. So research that it's the same thing. It's a self-claim. Unless you publish it and make it public domain, then someone else can try the same thing and say, okay, it worked. And that's what leads to citations. So as I showed earlier, published research is further validated by the number of citations. 100 people or 47 people or 10 people found this useful. And that means they tried to reproduce this and they found it useful. So educational value is when you take research into the classroom. There is some evidence to this as well. So for instance, the AI lifecycle that I showed is something that I share in the classroom, and that helps me to teach the students about AI and how to use it. It can go into government as well, so policy development. So government will be interested in, especially now these days, governments want to know how best to use AI for as many people effectively. And then more personally, it adds to your reputation. So if you are a budding master's or PhD student, or potential PhD student, in your PhD application, you can list the research papers you've written and the number of citations and maybe some of the review comments. And also, if you are a PhD student, it adds to your reputation, your CV. The larger the number of research papers, conference, or journal, the better it is for your reputation and career advancement for any other academic as well. So where you publish matters, and we start right at the top. So journals are the ideal places. Well, some journals are equally good for conferences, so I won't say ideal, but journals are more substantial in terms of what they expect a research article to be. So if you are an aspiring researcher and you are fairly young, then you can aspire to publish in Nature or Science in 20 or 30 years' time. So this is the aspiration for most academics and researchers to publish in one of these journals, and they have very strict criteria. So if you've seen some of the papers published in Nature, I think Nature is open access, some of the papers, so you can go and have a look. Just go Nature, Springer Nature journals, highly cited journals, for example, and you'll find those papers. And it's good practice to subscribe. I think they have a newsletter. Subscribe to those two newsletters, and you'll find lots of useful material in there. The journal indexing is important. In the interest of time, I will leave this one out, but suffice to say that the journals are ranked based on their impact factor, something called the impact factor. So I'll just quickly show you the Scopus ranking. If it loads, we'll come back to coming up. Let's go for something simpler. Yeah, interesting. Something's wrong with this.
Professor, you have to select, so there's option to select the title and publisher.
Okay, yeah. Title. Yeah. Publisher. Sorry. Okay, I got the two mixed up. Okay, let's go.
You have to select the publisher.
Publisher. I thought journal title. Okay, we'll come back to this. I think something's wrong with this website. Yeah, so indexing is ranking of journals. So just like we have ranking of universities, for example, the journals are ranked based on the number of citations they've received. So it's a complicated space. If you like, we can talk about this later, but we'll leave it there for now. And then what OpenAI DeepMind does is they publish papers in preprint, which is archive. Archive is one example. So let's see if I remember a paper published in archive. Maybe Transformer. So Transformer is the algorithm for the GPT, or most generative AI models. I think it's not called attention. Yeah, so that's the paper published in archive. So if you're really good, you would publish here. And it's 15 pages, 5 figures. So this is not peer reviewed because they know it's so good that they don't need anyone else's comments. So if you look at the number of citations, it is through the roof. So it's been cited 111,000 times. Yeah, compared to, like, if you get to 100, great job, but this is amazing. This level of citations is that people have actually used your model quite extensively, and it really helps them. So this is validation. This is universal validation. That's what you should aspire to achieve. So archive is, if you're exceptional, then you publish in archive, but maybe you and I are not. And that's why we look at conferences. So journals are hard, archive is for outstanding. Conferences are more accepting of small but innovative ideas. And that's what we try to do with this hackathon. So we have some funding and some interest, a lot of interest from you, but we don't have too much time, and also we don't have the experience. So some of the teams, you are new to the field. So taking all of these into account, we look at publishing in conference. So even with conferences, the IEEE alone has more than 2,000 conferences. There's too many to pick from. So ICON is one of the 2,000, but it is also prestigious. So prestige is that the conference has been running for 50 years, and it's attracting at least 1,000 people every year. So these are metrics that shows the conference is sought after by the research community, the global research community. Prestige is not enough. So it also must be coupled with visibility. So what happens to your paper after you published? And ICON is known for being a conference where the papers actually get cited. That means people actually read these papers after they are published. There are many conferences across the world where the paper is not read, it's just published, and no one really reads it until 3-4 years later. You might get one citation. So that's not really great. And because it's generative AI, we are hopeful that your papers will get so many citations as well. That's the reason we selected ICON. It's prestigious, it's high visibility, and it's not as challenging as a journal, and it's not as demanding as what would be usually published in things like archive. Okay, so what are the forms of academic writing? So this is more general knowledge: journal articles, conference papers, theses or dissertations, abstracts. This is common in medicine or in primary healthcare, where you only publish the abstract, a structured abstract, and you don't write the whole paper. For conferences, but not so much in engineering or other STEM disciplines. Book reviews, some people publish bibliographies or case studies, which are not highly useful, but useful in some ways. So conference papers is what we are looking at. So what's the structure of a conference paper? We start with an abstract, introduction, related work, research method, experiments, results, discussion, conclusion. So I won't spend time going into details of what each section entails, because this is your riding the bike moment. You have to start writing this to understand what exactly goes in there. So very briefly, the abstract is a 200 or 300 word version of the entire paper. So you try to summarize all that you've done in the research project to 300 words. And when someone reads the abstract, they have to very quickly register what this paper is about. So I think on the next slide, so academic writing is different to any other writing or any other type of communication, because you might be the best AI researcher in the world and you get the best experiments and results, but if you can't communicate this outcome to a third party, then your research doesn't travel too far. So it's not just experiments and data and results. It's actually communicating this in a form suitable for your target audience. So you want like-minded AI researchers to understand what you've done, starting with the research question, the methodology, challenges, experiments, results, and discussion, so on. So you have to strike a balance between the technical detail, which is mostly in the research methods or the experiments, the clarity of what you're trying to do and what you have accomplished, and making sure that the entire research paper is comprehensible. So you can't just I see this in some of the research papers where you just you repeat the same thing, or you use a lot of words to describe something very simple. So this is not the nature of academic writing. Academic writing is precise. You have to get to the point very quickly. And each word that you use in the sentence has to have a meaning. So you can't say, my AI model is effective and efficient and productive, because there's three words which are overlapping. And can you prove your claims? What is effective? What is efficient? What is productive? What is high performing? So you have to have a clear metric that comes up in the research method to prove your claim that your research is really good. So you need to strike this balance between how good your research model has been and how good your research writing will be. So abstract is that short, concise version. Introduction is a longer version that introduces the paper. So this is a bit of a challenge, because what is the difference between abstract and introduction? The abstract compresses the entire paper, so including experiments, results, discussion, and concluding comments, whereas introduction is introducing your research problem, the background, and what your contribution is going to be, and also you describe what the rest of the paper looks like. And then you start with the related work, because you have found 10 other people or 100 other people working on this topic. And then you start to summarize. If it's 100 people, then maybe there's 5 teams. So you group them into teams of 20, and then you have, say, 5 paragraphs in related work. So this is one approach, one of many approaches to writing the paper. I'm just verbalizing what's coming to my head right now in terms of one method, but there's many different methods of doing this, right? So related work has 5 paragraphs or 6 paragraphs. Usually you keep it to a minimum of about 1 page, because anything more means that you don't have too much contributions to talk about, and you're talking about other people's work. That is not helpful. And then a bulk of the paper should be focusing on research methods, experiments, and results. So this is fairly self-explanatory. So research method is the structure of your AI model, or the approach that you followed to create the new algorithm or create the new model, and then leading up to the experiments. So you describe the data sets, you describe the experimental setting, you describe the computers that you use to run the experiments, and then you talk about the results. And then finally, leading up to a discussion section, which talks about how good the results were in comparison to the literature. So you actually connect related work to results in the discussion and compare what you've discovered and what others have discovered, and then also opportunities for future work, and maybe even talking about what this means for the practical application of the research. So moving away from just research into the practical applications. That's a discussion point as well. And then finally, conclusion. Some people say conclusion is an upside down introduction, where you start by talking about what you tried to achieve, or the closing bracket, so the opening bracket of the introduction, what your research objectives were, what you tried to achieve, what your results were, and then what your results mean for the broader context of the problem domain you're talking about. So this is the structure of a paper, and one size does not fit all. So there are so many different research papers that you can have a look at, and you will see that different approaches. But this is a structure that's familiar to the ICON audience. And in terms of a page length, a conference paper, especially for ICON, is fixed at 6 pages. And you can go into an extra page, but that is charged. So let's try to limit to 6 pages. So you start with abstract, 300 words. Introduction is potentially. So let's look at. I tried to open. Yeah. So this is the template. If you are not using Overleaf, I would recommend using Overleaf, and there is a bit of learning there as well, training, which I think Lakshita will share with you online sources for how to use Overleaf. There is also Word format. So this is the template. Actually, I should start from the beginning. Yeah, so if you go to the ICON website and then you go into authors and then you find paper submissions, and then they talk about this. So here 6 full pages. This is the template. And if I click on that link, excuse me, takes you to this format, to this IEEE page. But I have a slight problem with this template because when you open it, it looks like this, and we're losing a lot of space for this weird structure of author affiliations. So instead of that structure, I would keep it to lines. And I think Lakshita will share the format with you later. There's another way of showing this, because if you have 6 authors, you've lost a good 10 lines of text, or at least 5 lines of text. So 6 pages, and abstract. We start with the abstract. Then introduction is usually, you'll take up these 2 columns. Again, don't quote me on this. It is just a rule of thumb. It's a very simple baseline. Your research should not be limited by a word count or a page count. I'm just using this for you. I'm just saying this to you because it's useful as a guide. So how much time you should spend writing different parts of this. Thanks, Lakshmi. You can find the links on the chat window for the Overleaf template. So introduction, abstract introduction, the first page with the author affiliations. It's fine if your introduction is does not cover the entire first page. That is maybe slightly better, that your introduction is shorter than all the rest of the first page, excluding abstract. And then you get into section 2, which is related work. Related work, usually 1 page or 1 column or half a page is good, or 1.5 columns. When I write papers, I would leave related work. I will have some dot points in related work, but I will leave it as a last step, as my last writing, because I don't want to lose time writing additional related work when I actually need more space for methods and contribution and experiments. So again, with disclaimer, my practice is to start with methods, experiments, and results, and then come to introduction related work, because then I know exactly how much space I have to write the rest of the paper. But also keeping in mind, word count is not a limitation. It should not be an obstacle to how good your research is. So if you feel like writing more related work, you should be, the publisher or the journal or the conference should allow you to do that. Yeah, so 6 pages. Now we've done 1 page. And if you think of the remaining 5 pages, we need at least 1 column or 2 columns, 1 page or half a page for references. It's very important. And that means we are left with, approximately 4 pages or 4.5 pages. So, and that is, let's go with 4 pages, because related work is half a page. So in that 4 pages, you have to really bring out the value, the contribution of your research. And that's what leads to after publication. So publishing the paper is a short-term goal, but it has to be read. It has to be useful. That's where your research outcomes have to be something that's interesting for the audience. So on that note, I'll go into a couple of papers we've published in the past. Again, self-promotion, but I think these papers are good. So you can see, I think you can see my screen still. So this is the format of the authors that I prefer. So we have it, we have it in this line by line format, not that blocks. So abstract keywords are also important. So keywords means your research is easily discovered by authors interested. So introduction in this case is not the full remaining space. Excuse me, it's almost one column. And then background is also one column. So in this case, we wrote the introduction and the background after we have completed the method. Section 3 is the method, so it's a proposed approach or proposed model or new algorithms or similar wording. Diagrams are important, and then notation, so some notation of the algorithms we've used. The algorithms are described here. So that's the proposed method is one column, 2 and 3 columns. So that's 1.5 pages. Experiments and results are 2 pages. So that's your approximately 4 pages. And discussion and conclusion is also important. So there has to be a conclusion. So that's the 4 pages. And then references are about half a page or 1.5, 3/4 of a page. And that's it. So say for example, if I wanted to increase space for writing, I could have made these images smaller. There's a lot of space lost over here, just blank spaces. But in this case, we've just dumped the images there. This is another paper, not IECON. I believe this paper was IECON, 2018. This one, see that is 7 pages. So don't write 7 pages because we have to pay the extra page fee on your behalf. But in this case, the introduction is too long. So it's gone a bit over. I wouldn't recommend this. I would stop somewhere there or just finish it in the first page. And related, maybe the introduction has some related work because this related work is smaller. So in that case, it's okay. But still, I would have had related work starting over here. So section 2 starts over there. Proposed approach is good. That's half a page. Half a page. So that's 1.5 pages. So see that there is an approximation there. So you've seen 2 pages, 2 papers with 1.5 pages of research method. And then experiments and results. So it's about 1, 2, 3, 4. So that's 2 pages. Experiments and results have taken 2 pages. And then conclusions and references. This is also good, or maybe not so good. Too many references. I'll try to keep it at this point. So this is really because the conference has to pay a fee to publish each page with the publisher, IEEE. And that means we've paid extra for just references. So this is something you should try to avoid, but this is just in the details. And this is a journal paper just for reference. Also, I've been part of this authorship team. Introduction is a bit longer. Journal papers go up to 10 or 8, starts with 8 and then maybe 10 pages. Related work. And here the methodology is quite extensive, as you can see. So it has subsections. That's 1, 2, 3. So almost 3 pages. And then evaluation is another close to 3 pages, and then conclusion. And it's a very old picture of me. All right. So on that note, I think I've covered everything that I wanted to. Oh, so the last one, your friend, yes and no. So a strong no for using the tool to write, because that will get you nowhere. You'll be caught out by things, plagiarism checking, so things like Turnitin or Authenticate. Even if they don't catch you there, your paper is worthless because no one is going to read. Any other researcher who sees GPT style writing in there will not really pay attention. So if you start the abstract with GPT style writing, people will recognize this good researchers will recognize this and not even bother to read the experiments and results, because you have sort of misled them, or you have devalued their effort in reading your paper by using AI to write. The conferences and journals actively discourage you from using the tool purely to write. So that's a strong no. Do not use it. But a yes, a mild yes, is to improve your writing. So you have your first language is not English, and that means you have to think in your own language, and you translate that into English when you start writing. So there might be some words that don't align, or the grammar doesn't align. So it's in that case, to improve your writing, what you have written, you can use GPT to improve your writing. So in this case, the writing is yours, but you're using a tool to improve this. Just like we use in Microsoft Word, we go right click and we look for synonyms. It's similar. It's similar in principle. We're using GPT to improve your writing, not just synonyms, but the overall sentence structure, grammar, and so on. So that is allowed and that is encouraged, really, because we want to make research open to every nationality in the world, not just the countries that speak English as a first language. It has to be accessible to everyone. And in that line of thinking, GPT is the good fortune to make sure research is transparent, open to all communities, all languages, all nationalities. So use it to improve your writing, but not for the actual writing. And also, when you use it for improving your writing, you have to make sure that every word counts for some meaning. Because at the moment, if you start using GPT, it will add a lot of superlatives like amazing, outstanding, incredible into what you're trying to say. And the moment a researcher sees these kind of words, we know this is not good research. This is just someone trying to do half a job. So the superlatives have to be toned down, and each word has to have meaning. So it's a bit of back and forth, but when GPT improves your writing, you can find out the meaning of these words that they've added if you don't know the meaning, and then you think in your own language or in the language of your mind, if that actually makes sense, or is that trying too hard to write better. That's what GPT tries to do, because it's a collection of words that it doesn't know the meaning of, and that's where it fails as well, because it becomes predictable, it becomes recognizable very quickly. Okay, so I may have spoken for too long. I'm going to stop there and ask for any questions. And the questions can come when you start writing, not 40 questions all at once. But if we can think of a process to answer some of your questions when they start appearing when you start writing. Okay, on that note, I'll stop sharing, and we can share these papers because it's a closed community. The 3 papers I've shown you, I can share those with you as well. And we are in the process of creating an email group so we can share things in that closed setting. Okay, any questions?
Hello, Prof. Thank you so much for this good presentation. Actually, I have one question, because basically I'm from chemical engineering background, so I just want to confirm one point regarding the data, because data set required, like how big is it? How big is big actually? This is which one is very critical, like totally rejected, and which one is acceptable, which one is recommended, like that, because it's very general. So I just want the critical points.
Yeah, thanks, Sulafat. I think we spoke earlier as well. I think the question, the size of the data set is more secondary compared to the novelty of the research. So that is the benefit of writing a conference paper because they don't have a very high expectation like a journal. And that means if your research method is good and you have demonstrated some research contribution, even with a small data set, the conference will accept this. So I wouldn't worry too much about the size of the data set. If your research question is good, and I think your research question is really good because it's very current and so on. I know this because we've had a prior chat. So yeah, that's my position. So it should be fine.
Thank you so much.
So there's a question online. That methodology part, can you give me a brief explanation about that, or like, can you give us a format? What needs to be included and how it needs to be included in the diagram? Yeah, good question. So this is one of the hard ones. It's the riding the bike challenge. You have to. So okay, the first method I would follow if I was a student. Or as a student, I would have followed the same, is to look at a similar paper and how the research method has been described in that paper. Not to replicate it word to word, that is plagiarism, but to get an understanding of how to write the research method. So fortunately, there's lots of AI research, and that means we can use that as a template or format to understand how to write the method. So that's one approach. Another approach is to think of your contribution logically. So you have a research question, and then the research question translates into research objectives. Now, can I draw a diagram of this? And one good thing with AI research is that this block diagram approach is quite useful because we have data sets, we have generative AI models as blocks, and then we can have this almost input-output type flowchart of what data goes in, what outcomes come out, what kind of hyperparameters go in. So you can start drawing this from your research objectives, and that will also be a start for your research methods. And then you can maybe cross-check what you have drawn with what is published in research, in published research, and that gives you an understanding of where you can improve that diagram. There is, proposed methodology diagram should be in research methods. So if I go back to my slide. So research objectives, we don't say these are my research objectives in the paper. We write it, we blend it into the introduction. These are the research contributions, like I've shown in here. So if you think of, without getting into the details of this paper, so it's right here, the research objective becomes a couple of sentences or a paragraph. So this is all problem description. And then towards the end, we say we are going to do this to solve this problem. And then we don't go into details there. Maybe you can write a couple of more sentences, and then we say this is the rest of the paper. So we're trying to solve this problem using this method. And this is the paper that communicates this method. And then we switch back to literature. And then we go proposed sections. So the section 3 starts with the research method. So research method starts by saying, look at this diagram. So in this case, figure 2. Yeah. So now we're starting to describe what the proposed method looks like. And then it gets into the algorithms and so on. So that's one way of looking at it. And yeah, it's a bit challenging for me to communicate. So it's more like an architecture diagram. Yes and no. So again, my short and easy answer is depends on your work. So is it the model architecture? Yes. if your model architecture is the novel contribution. If it's something from related work, you have to cite it. So, for example, this figure 1 is not our work. It's from another paper, and that's why we have cited it, saying this image is from another paper. So, if the model architecture is novel, yes. The other paper probably has in this one. Yeah, this one does not have an image, so that is also possible because we described it in text. So the approach is presented in 2 subsections, and it's all text with some notations of the data and the attributes properly. Yeah, so each paper is kind of unique, and then if I go into this journal paper, this is fairly, yeah. So this is called the functional view of the ISTF. So this paper proposes ISTF. There is an overview of what happens. So this is like a anomaly detection in video footage, live surveillance, learning, detection, aggregation, and then we expand that with some notation. So this is what happens when the data is received by this algorithm. And then the CNN layers and something else, anomaly detection, localization. So yeah, I can't say directly. So I can't. It's almost like I can't say it's black or white. It's in between. It can be a mix of black or white, or with red and blue and so on. So it is. It depends a lot on your research method and your contribution, but it definitely needs text and images. It can be an architecture diagram, it can be a flowchart, it can be an approach diagram, a high-level overview that you break down in the subsections of the research method. So you need to read a few research papers. Yeah.
And also, this is something that they can discuss with their mentor and then get their help.
Yeah, exactly. Yeah. So if you come up with a couple of images, then the mentor can say this is useful because the mentors have written many research papers in the past, and you have to read the papers yourself. So find papers that are very similar to yours, and there's many, and start reading those.
And so now we are 12 minutes going ahead of our deadline, so we can take another one question. So if not, so thank you, Professor. Thank you so much for sharing your knowledge and giving all of us a clear understanding of what is expected as an academic manuscript. And for the rest of the participants, so there's one notice that I have to give you. So tonight, so we have the deadline for the milestone 1, and for the milestone 1, we don't evaluate that much on your submissions because we are asking for the methodology and the prior work and the abstract. You might be able to get get a support from your mentor, or you might not have. So because given the quick deadline, so whatever the submission that you provide, you can change it for the milestone 2 with after discussing that with the mentor. So what I'm expecting you guys is like, so submit whatever the document that you currently have, and then that might not be the final submission for the milestone 2, but you can proceed, you can improve it further with the help of your mentor. So tonight deadline is fixed, so we won't be extending it any further, and hopefully you guys will proceed, and then we'll stay in the hackathon. Then thank you so much. And then there's one question from Fatima about the page limit. So the 2-page limit that we have asked you for the milestone 1 submission, you can extend it. So, but final, as Professor mentioned, so the icon paper can only be 6-page. So there's like a hard limit on that one. So your final paper, you can get the help of your mentor and then reduce the page count based on your contribution. So if that's all, so Again, thanks, Professor. And thank you all for joining us.
Thank you. Good luck writing.
Thank you.